Welcome to today's Explainer. So today we're tackling a really fascinating physics mystery, the silent space mystery. We're going to break down the invisible mechanics of how energy actually moves through our world. If you've ever wondered how sound reaches your ears or why certain places are just dead silent, well, you're in the exact right place. Let's get right into it.
Okay, picture this. You've got two astronauts on a spacewalk, right? They're floating way up high above the Earth, working hard, maybe repairing a metal arm on the space station together. It's this absolutely stunning scene, out there in the vastness of space. But it actually sets the perfect stage for a very specific, kind of wild practical problem.
Here's the big question for you. Can those astronauts actually hear the sounds of metal clanking as they work? I mean, if one of them accidentally smacks the metal hull with a heavy wrench, does it make a loud bang like it would down here on Earth? It really makes you challenge your assumptions about how sound travels. We're just so used to hearing literally everything around us that we rarely stop to think about the invisible mechanics making it all possible.
To figure out this space puzzle, we first need to lock down one fundamental rule, and that is that sound completely relies on something called a medium. So what's a medium? It's simply the physical material, whether that's a solid, a liquid, or a gas, that sound travels or propagates through to get from its source straight to you. The air in the room you're sitting in right now, that's a medium. The water in a swimming pool, also a medium. Sound is this energy that absolutely 100% requires physical matter to get around.
So let's immediately contrast that idea of a medium with a vacuum. A vacuum is just a space where there is no medium, no matter present at all. Zero. It's entirely empty space. And honestly, this right here is the key to our whole puzzle. Why? Because outer space is essentially a near vacuum. It's practically devoid of all the matter, the gases, the air, basically all the stuff we take for granted down here on Earth.
All right, let's jump into section 10.2.1, an activity to prove that sound needs a medium to propagate. We're going to treat this explainer like a real hands-on activity video today. We're stepping right into the lab to run through the absolute classic vacuum bell jar experiment.
Okay, I want you to really picture yourself doing this activity. First, you take an electric bell, you put it inside a sealed glass bell jar, and you turn it on. Obviously, you can hear it ringing loud and clear right through the glass. But then, you turn on a vacuum pump that's attached to the jar, and it starts sucking out the air inside. If you listen closely as the pump does its thing, as that air gets pulled out, the ringing sound gets fainter and fainter and fainter until eventually it just fades to complete, almost eerie silence.
The contrast here is just wild to witness. With a normal bell jar full of air, the sound is super loud and clear. But once you hit that near vacuum state in the evacuated jar, you hear absolutely nothing. I mean, you can literally see the bell's little hammer striking the metal. The action is still happening right in front of you, but the sound, it can't reach you. And you know, the very second you let air back into that jar, the sound instantly returns. It's the perfect proof that without the air, without our medium, the sound just cannot propagate to our ears.
So the absolute crucial takeaway here is this. Sound is vibrating energy. It doesn't just, magically teleport from an object straight into your ear. Actually, scratch that. It's more like a chain reaction. It originates as a physical vibration that sends energy outward into the surrounding environment. And if there is no environment, like if there's no matter at all, well, there is just nowhere for that energy to go. Let's break down exactly how this energy actually moves. Whenever you have a vibrating source, maybe it's our ringing bell or that clinking tool in space, it transfers its energy to the surrounding medium. The tiny particles making up that medium start to vibrate and oscillate back and forth. As they do that, they bump and crash into their neighboring particles, passing the energy forward. It's exactly like a bucket brigade putting out a fire, just handing the bucket down the line from one person to the next. But here's the catch. Without a medium, meaning without any solids, liquids, or gases, your bucket brigade has literally 0 people in it. The energy just stops cold, and that perfectly explains why our vacuum bell jar goes totally silent. No particles crashing into each other means the vibrating energy has nowhere to travel.
All right, so let's finally resolve our big opening space puzzle. If our astronaut smacks the space station with a big metal tool, it is not going to make a sound that travels through the vacuum of space to their partner. Because space is a near vacuum, there's no bucket brigade of air particles out there to carry the sound. So how in the world do they talk to each other? Well, astronauts rely on special devices like microphones that are fitted right into their spacesuits. These microphones capture the sound waves traveling through the tiny bit of air trapped inside the astronaut's own helmet. Then, they convert those physical voice vibrations into electrical signals that can just be beamed wirelessly. Pretty genius, right?
Which leaves us with this final, kind of fun thought to ponder today. If sound definitively requires a physical medium to travel, and we know outer space is a vacuum, just how many sci-fi movie space explosions have you watched that are, well, completely scientifically inaccurate? Think about it. The next time you're at the movies and you see a massive starship explode with this huge theater-shaking roar out in the vacuum of space, you are going to know the silent, scientific truth. I really hope this explainer gave you a fantastic new perspective on the invisible physics happening all around us every single day. Keep questioning things, keep observing, and I'll see you next time.